Welcome back. Today we're going to talk about parametric curves and parametric equations and what that looks like to graph, what a parameter is, and just the basics of how do I work with these, and how do I do some things with parametrics and motion. And so here we go. A parametric curve. We talked briefly this year about parametric curves and parametric equations, um, but a parametric curve is a graph of ordered pairs and that would be like xy, where we have equations that define x and y. So for example, x is going to be equal to f of t, and y is going to be equal to g of t. Okay, so x is going to be defined by an equation in terms of t. Y is going to be defined in terms of an equation in terms of t. For example, it might look like x is equal to t squared and y is equal to 4t. Okay, so this would be an example here where we have x in terms of a t and y in terms of a t. Well, we also, for parametrics, are defining them in terms of an interval. And so, parametric curves and parametric equations work together because the curve is a graph of the equations. So I is going to be an interval for which t is defined. Okay, so for which t is defined. And this whole explanation here is under both of these. So this would be like parametric curve and parametric equations. The equations are the f of x is equal to f of t and y is equal to g of t. Okay, and so parameters, like we talked about earlier in the year, we talked about an example where if there's a store and they sell ice cream and sunblock, as ice cream goes up, sunblock goes up. So the sales of ice cream go up, the sales of sunblock go up. As the sales of ice cream go down, the sales of sunblock go down. Well, they're not necessarily related, but they're both related to temperature. So they're both related to the variable t. As t rises, sunblock goes up and also ice cream goes up. So they just happen to step together, but they don't necessarily they aren't necessarily defined by one another. Okay, and so what we're going to do is we're going to find out how do we graph these things. And so tomorrow in class we're going to talk more specifically about how to graph on our graphing calculator because it's easiest that way. But a couple of things, graph, this is going to be with a calculator. In parametric mode. Okay, and so a lot of these things actually we can do without necessarily knowing how to graph yet, which is why we're going to go on. But tomorrow in class we're going to talk more specifically about, what do these graphs look like? How do we set them up? What do we need our window to be? And why is this notation so funny on my calculator? Okay, so we'll talk about that tomorrow. In the meantime, let's talk about what we can do with these parametric equations. What we can do with these parametric equations is we can say, if they're both defined in terms of t, we can eliminate the parameter. So eliminating a parameter is eliminating t. Okay, so eliminate the parameter and identify the graph of the parametric curve. So what we're going to do is we are going to, one, solve for t, 2, substitute into the other equation. This won't be unfamiliar to you because we've done this when we've done like systems of equations. So for example, so I'm going to solve for t and then substitute into the other equation to eliminate t. So here we go. When I solve for t in this equation, I'll have x minus 1 equals negative 2t, and I'll divide by negative 2. And so when I do a little bit of rearrangement here, I'm going to end up with 1/2, because -1/-2 is a half. And then this will be 1 minus x here is equal to t. When I do that, I got to substitute this back into my other equation. So I'm going to have y equals 2 minus 1/2 times 1 minus x. So 1/2 times 1 would be a half. So 2 minus a half would be 1.5. And this would be minus a minus, so minus 1/2 times minus x would be plus 1/2 x. And so what I'm left with is y equals 1/2 x plus 1.5. It's asking me to eliminate the parameter, identify the graph of the parametric curve. Well, this is a line with slope of 1/2 and a y-intercept of 1.5. And that's the thing about parametrics is we end up with a line or a parabola, or maybe we end up with a circle, because taking those two things that are defined independently, putting them together, gives me an equation that I recognize. So why would we want to do this? Well, we start to define things in 3 dimensions, and we start to define motion, and it helps us to have this third-party parameter that we can use. All right, let's work on another one. In this case, I've got a t squared minus 2 is equal to x, and y is equal to 3t. To eliminate a parameter. Now, if you want to pause here, you can and try this. I'm going to keep going, but you can pause and try it and then check your answer. I'm not going to deal with the quadratic here. I'm not going to deal with the squared one. So I'm going to say x is equal to t squared minus 2. And if I solve for t over here, this is going to give me t equals y over 3. So now I'm going to put the t right back in there. So this is going to be y over 3 squared minus 2. And so x is equal to y squared over 9 minus 2. I can add 2. So I've got x plus 2, and then I'd multiply by 9 and have that equal to y squared. Well, what we're going to find in a later chapter is we actually know a little bit more about this, and we kind of do from way back in the day, but it's a sideways opening parabola. And so that would be identify the graph. We'd be able to look at it and say, hey, oh yeah, I've got a parabola that opens sideways. So that's solving for the parameter. Okay, then they're going to give us something like this. So I've got cosines and sines and parameters on t. And what I want you to understand here is here's a strategy that's going to help us out. When we come across something that's defined in terms of sine and cosine, especially if I've got something multiplied by cosine and sine, what I can do is I can combine my parameters into x squared plus y squared, and you're going to see what's going to happen, and you might be wondering, like, well, why would I do that? Well, what I'm doing is I'm trying to eliminate the parameters, and so watch what happens. If I do x squared plus y squared, really I'm going to have 2 cosine t squared plus 2 sine t squared. And what ends up happening is I have 4 cosine squared t plus 4 sine squared t. And if I factor out a 4, I've got 4 times cosine squared t plus sine squared t. And if I remember from my trig ratios, this is actually 1, so it's equal to 4 times 1. So x squared plus y squared is equal to 4. And this is a circle with radius of 2. Okay, why did that work? Well, when you've got sines and cosines and you're trying to eliminate a parameter, square both of them and add them together, and that will give you an equation that's going to help you define that in terms of an equation without a t in it. Okay, so we're going to find the parameterization of a line through the points A is equal to -2, 3, and B is equal to 3, 6. When we do this, there's an equation for this. Parametric equations have 2 parts, an x equals and a y equals. My x part, when I have 2 points, is going to be defined like this. I'm going to do x1 plus t times x2 minus x1. And my y is going to be y1 plus t times y2 minus y1. Okay, so it's going to take into account both points. So if I'm going to find the parametrization of the line through these 2 points, this is going to be my x1, y1, x2, y2. And so this means 2 equations, and x equals and y equals. And when I do that, I'm going to get this. x1, so -2, plus, and then I'm going to have t, because my parameters have this third variable, this t. And then it's going to be x2 minus x1, so 3 plus 2, because it's minus a -2. And so my x equation is -2 plus 5t. My y equation is 3 plus t times 6 minus 3. And so it's 3 plus 3t. So what's my answer? This is my answer. Both equations here based on my equation to find the 2 parametrics of between the 2 points. Okay? So that's the first part of this. Tomorrow we're going to talk about more of the applications here and do a couple of sample exercises with it. But that's the basic gist of parametrics, guys. Thanks for watching, and we'll see you next time.